Um, have you ever had that incredibly frustrating experience where you spend an entire afternoon explaining a really complex project to an AI assistant?
Oh, yeah, like constantly.
Right. You get everything perfectly aligned. You establish your formatting rules. You troubleshoot, I don't know, 3 different bugs, and you finally get the code humming perfectly.
And you feel like you finally got a rhythm going.
Exactly. Then you come back the very next day, say hello, and realize it has completely forgotten who you are.
It's the worst. It's like you're a total stranger again.
You're forced to start from scratch. You're copying and pasting old prompts, trying to get it back up to speed while it cheerfully offers you beginner-level advice. It is exhausting.
It really is. It totally breaks the flow of any real work.
Well, today we are looking at a system designed to cure that specific headache. We are doing a deep dive to
For Remember Me, Refine Me.
I love that name.
Yeah, it's clever. It's a project created by AgentScope AI that essentially gives agents a persistent, evolving memory. And just looking at the source material from their GitHub repository, this project already has, I think, 1.3K stars and over 100 forks.
Wow, it's moving fast.
It really is. Developers are clearly hungry for a solution to this problem because it represents a fundamental shift in how we collaborate with machines.
For sure. So our mission for this deep dive is to explore exactly how this toolkit is curing AI amnesia and why that is going to radically change how you interact with AI moving forward. We're going to look at the architecture, the philosophy behind it, and how you can actually test it out on your own machine.
Yeah, and to understand how ReMe achieves this, we first have to look at the architectural bottlenecks it's bypassing. The developers identify 2 massive, interconnected problems in the current agent memory space that force this amnesia upon us.
Okay, let's unpack this. What is the actual problem here? Why does your AI keep acting like it just woke up from a coma every time you open a new tab?
It really does feel like that.
It does. So the first bottleneck they point out is the limited context window.
Right.
And you can think of a context window as the AI's short-term working memory.
Yeah, it's a hard mathematical limit on how many words or tokens the model can process at one time.
So how does that play out in a real project?
Okay, so imagine you're working on a massive Python web scraper over the course of a week.
Okay, I'm with you.
On Monday, you set up the basic directory structure. On Tuesday, you spend hours dialing in the error handling for rate limits. By Wednesday, you ask the AI to optimize the scraping loop, and suddenly, it breaks the error handling you perfected yesterday.
Ah, because it forgot Tuesday.
Exactly. The AI didn't maliciously delete your work. The early parts of your conversation simply got pushed out of its short-term memory. It literally ran out of space to hold the active text of your Monday and Tuesday chats.
That makes so much sense.
Yeah.
And the second problem really compounds that issue. The developers call it stateless sessions.
Right, stateless sessions.
This means new conversations cannot inherit the history of old ones. You close your browser tab, your laptop goes to sleep, or you close your terminal, and poof, the session is gone forever.
Gone.
The next time you log in to build the next feature for your web scraper, the AI starts from an absolutely blank slate.
Which is why traditional AI is essentially trapped in a perpetual loop of first introductions. It can never build a cumulative understanding of you, your preferences, or the nuanced history of your ongoing projects.
It's basically Groundhog Day.
It is exactly Groundhog Day. ReMe solves this loop by automatically condensing those older, sprawling conversations and persisting the important information into long-term storage.
Okay.
So when you open a new session on Thursday, the agent can recall the directory structure from Monday and the error handling from Tuesday without you having to re-upload a single thing.
That is massive.
It really is. It allows the AI to learn and adapt to you over time rather than just reacting to your immediate, isolated prompt.
You know, how it actually stores that memory is arguably the most surprising part of this entire project for me.
Oh, absolutely.
They call it file-based ReMe. Instead of locking your AI's memory away in some opaque, hidden database that you can never see or touch, ReMe stores its memory as plain, simple Markdown files right on your local hard drive.
What's fascinating here is the sheer transparency of that approach.
Yeah.
In traditional enterprise memory systems, the data goes into a complex vector database or a SQL backend. It's a black box to the user. You cannot easily verify what the AI believes to be true about you.
Right, it's just hidden away on a server somewhere.
Exactly. If it makes a mistake, correcting it is incredibly difficult. Furthermore, migrating that memory to a different system or a different computer is practically impossible without specialized tools.
But the philosophy ReMe adopts is literally memory as files. Files as memory. Because they are just standard Markdown text files, you can open them up in whatever text editor you prefer and read them anytime you want.
Which is so refreshing.
It is. You can see exactly what the AI has recorded from your sessions. Let's say the AI misunderstood a sarcastic comment you made and wrote down that you hate using the React framework when you actually use it daily.
Right. It just took you totally literally.
Exactly. You don't have to awkwardly prompt the AI to forget it. You just open the Markdown file, delete that sentence, and hit save.
You've just performed direct brain surgery on your assistant.
Boom. Done. And if you want to move your AI to a new laptop, you just drag and drop the folder. It is perfectly portable.
To manage all these files without overwhelming the user, the core class of the file-based system acts like an intelligent secretary. It handles the administrative burden of memory management behind the scenes.
Like a background process.
Yeah, exactly. When you start the system, it initializes local file storage, boots up a file watcher, and gets an embedding cache running.
I want to pause on that for a second because that's a crucial piece of the puzzle. An embedding cache is basically a high-speed index that helps the AI instantly pull up the right concepts without having to reread every single file word for word every time you ask a question.
Right, it's an optimization.
Yeah, it translates your text files into mathematical coordinates for quick reference.
And it is constantly running these context checks in the background to monitor that token limit we discussed earlier. When you ask it a question, it performs semantic memory searches to find the right Markdown files, pulls that relevant history into the active context, and then writes new important takeaways back into those files as the conversation progresses.
So the file system handles the transparency, giving me this intelligent secretary that manages my Markdown documents. But how does the AI actually organize all those notes internally so it knows what to look for?
That's the million-dollar question.
Right. That brings us to the second system ReMe offers, which is vector-based ReMe. If the file system is the physical filing cabinet, the vector-based system is the AI's specialized neural pathway for categorizing that information.
This vector-based system unifies three highly specific types of memory. Understanding these three pillars is crucial for grasping how an AI using ReMe actually learns and improves over time.
Okay, break them down for us.
The first pillar is personal memory. This tracks user preferences and habits, and it's tied directly to a specific username identifier.
This is where it remembers the human behind the keyboard.
Exactly.
Going back to our Python web scraper example, personal memory is where it notes that you strongly prefer your code documented with inline comments rather than block text.
Oh, good example.
Or that you always want a summary of changes in bullet points before it shows you the raw code.
Yeah.
It is learning your aesthetic and communicative preferences.
And then the second pillar shifts the focus to the work itself. That's task or procedural memory. This is tied to a specific task name.
So it categorizes by the project.
Right. Here, the AI stores its execution experience. It remembers patterns of success or failure for specific objectives. If it tried to deploy your web scraper to a cloud server last week and encountered a bizarre firewall error, it records the exact sequence of terminal commands it used to bypass that error.
That saves so much time.
Doesn't it? The next time you give it a deployment task, it checks its procedural memory and avoids making the same mistake twice. It builds institutional knowledge.
That's incredible. And the third pillar rounds it out by focusing on the instruments the AI uses.
Yes, that is tool memory, which is tied to a specific tool name. Modern agents use various digital tools to get things done.
Like executing code or reading directory.
And browsing the web, yeah. Tool memory allows the AI to remember its experience using those specific instruments, including how to tune the parameters for the best results.
Could you give an example of that?
Sure. So if a certain weather API requires the date format to be year, month, day to work properly, the AI remembers that nuance in its tool memory.
Those three pillars really create a compounding effect.
They do. If we connect this to the bigger picture, separating memory into these three distinct buckets allows the AI to move far beyond basic recall. We're moving away from the era of prompt engineering, where you have to perfectly craft every single instruction to get a good result.
Oh, I hate having to write a paragraph just to get a simple script.
We all do. Instead, we're entering an era of relationship engineering. The AI learns your unspoken preferences, your project's historical quirks, and the nuances of its own digital tools. It's moving from a general-purpose language model to a highly specialized, customized expert that is perfectly attuned to your unique workflow.
But how does it actually decide what makes the cut? When you have a massive 2-hour brainstorming session, it can't save everything.
No, it would bloat the files too quickly.
Exactly. So when that context window starts overflowing, ReMe uses a component called the compactor.
I love the compactor.
It's so smart. Think of the compactor as an executive assistant sitting in the corner of the room, taking highly structured meeting minutes. It looks at the sprawling conversation and condenses it into specific categories so nothing vital is lost.
The structure of those compacted summaries is very deliberate. It extracts the goals, which is what you're actually trying to accomplish with the current project.
Right.
It notes the constraints, so any specific requirements like ensuring the code is compatible with an older version of Python. It records the progress, what tasks are completed, which are currently active, and what's blocking you.
Keeping track of the workflow.
Yes. It logs the decisions made, along with the reasoning behind them, so it doesn't question your architectural choices later.
Oh, that's huge.
And finally, it saves the context. These are key data points like specific file paths or unique function names that will definitely be needed again.
It basically turns an hour of rambling trial and error into a tight, actionable summary. But here's where it gets really interesting. How does it physically write this down into those Markdown files?
Right, the actual mechanism.
It uses a component called the summarizer, which relies on a React framework, and React stands for Reason plus Act. The AI is equipped with actual file tools, the ability to read, write, and edit files on your hard drive.
The AI isn't just passively receiving data and dumping it into a database. It is actively managing its own memory architecture through an internal monologue.
An internal monologue, yeah.
This cycle is fascinating to break down. First, it receives the new compacted conversation summary. Then it enters the reason phase. It thinks to itself, asking, what is actually worth recording here?
Once it isolates the valuable information, it moves to the act phase. It uses a tool to open and read the specific memory file for that day. Let's say a file named 2025a213.md.
It then goes back to the reason phase. It reviews the existing contents of that Markdown file and thinks, how should I merge this new information with the content that is already in here without creating redundant duplicates or erasing important past context?
It's evaluating its own notes.
Exactly. Finally, it acts again by editing the file to update it with the new synthesized knowledge.
I love the visual of that.
Yeah.
It is like watching a tiny, meticulous librarian living inside your machine.
That's the perfect analogy.
They're pulling folders from the cabinet, reviewing the new notes you slid under the door, carefully updating the permanent records, and putting the folder back.
But once that memory is carefully curated and stored away by our tiny librarian, the next challenge is getting it back when it's needed. How does the AI find that needle in the haystack a month later?
Right.
ReMe uses a hybrid retrieval approach, recognizing that relying on just one search method leaves significant blind spots.
This is where we get into the mechanics of how an AI actually searches its own brain. ReMe fuses two different search algorithms together.
The first is vector semantic search, which carries a weight of 0.7 in their fusion system.
Okay, 0.7.
Yeah. Vector search is brilliant at understanding the abstract meaning or the vibes of a query. Think of vector search as asking a bookstore clerk for a scary book about a hotel. The clerk understands the underlying concept and will immediately hand you The Shining.
Even though you didn't say the title.
Exactly. It captures synonyms and paraphrasing. If you search your AI's memory for earlier discussion about deployment, it will find the memory even if the original text actually said putting the app on the server.
But vector search can sometimes struggle when you need an exact token match.
Oh, definitely.
If you ask the bookstore clerk for the specific ISBN number of the 1980 paperback edition of The Shining, they might just stare at you.
They'll have no idea.
Sometimes you don't need the general concept. You need a highly specific error code or a unique convoluted variable name like config to fictminal.
That is precisely why they combine the vector search with a BM25 full-text search, assigning it a weight of 0.3. Yeah, BM25 is a classic keyword-based algorithm. Going back to your analogy, BM25 is like using the bookstore's computer terminal to search for that exact ISBN number. It is incredibly strong at exact token matches, demanding absolute precision, but it doesn't understand synonyms or context at all.
By fusing these two methods together, leveraging the semantic understanding of vector search for natural language and the pinpoint accuracy of BM25 for exact keywords, ReMe ensures that no matter how you ask the question, the search succeeds and retrieves the correct memory. It is the best of both worlds.
And the practical application of all this architecture is immediately accessible.
Which is great because this sounds really complex to set up.
It does, but the toolkit includes something called ReMe, which is a terminal assistant built right into the project. You can run it on your local computer, giving you a command line interface with a fully functional, memory-enabled AI that you can start using today.
It gives you direct, granular control over your session state through specific / commands, which completely changes the rhythm of working with an AI.
It really puts you in the driver's seat.
Let's say you've been working on a complex feature for 2 hours, and the context window is getting sluggish. You can type /compact.
/compact.
You are telling the assistant to manually compact the current conversation right then and there. It takes the history, creates that structured summary we talked about, and saves it to your long-term Markdown files in the background. But crucially, it keeps your recent active messages in the current window, so you can keep chatting without losing the immediate thread.
It's like saving your progress in a video game without having to pause the action.
That is exactly what it's like.
Conversely, if you want to pivot to a completely different task, you use the /new command. The system takes everything you've discussed, meticulously saves all that history into long-term memory, and then completely clears your active message window.
So a fresh start.
Yeah, you start a brand new, clean conversation, freeing up your context window, but the AI still fundamentally retains the knowledge from the previous session in its long-term storage.
And if you were just messing around testing a silly prompt, or if the AI went down a completely wrong path and you don't want it to remember any of that nonsense,
We've all been there.
you just use /clear.
Yeah.
This instantly clears everything from the active window without saving anything to the long-term memory files. It is total user control over what the AI learns and what it discards.
This terminal assistant acts as an autonomous extension of your own capabilities, augmented by perfect recall. It isn't just a chatbot. It is a true agent with built-in tools. Beyond the memory search tool, it can execute bash commands on your machine. It can list directory structures, read text and image files, edit files by replacing exact text matches, and write new files from scratch.
It can even execute Python code snippets right in the terminal to test its own solutions.
Which is incredibly powerful.
And it can perform web searches using the Tavily API. For those unfamiliar, Tavily is a search engine built specifically for AI agents, allowing them to pull rapid, real-time information from the web to augment their existing knowledge. It is incredibly capable.
It really is a powerhouse.
Oh, and in scanning through the source material, there is a fantastic little Easter egg hiding in ReMe. Since it was developed during the year of the horse, the creators added a /horse command.
I love this part.
If you type it into the terminal, it triggers an ASCII animation of a galloping horse, shoots off terminal-based fireworks, and prints random year of the horse blessings right there on your screen.
Seeing a highly sophisticated, multi-tiered AI memory management framework take a moment to generate a terminal-based fireworks display brings a welcome bit of levity to the dense technical architecture. It highlights the human element behind these open-source projects.
So what does this all mean? If we zoom out and look at the trajectory of the tools we've discussed today, ReMe is doing something profound.
It really is shifting the paradigm.
It takes AI from being a static, forgetful calculator that resets every time you clear the screen and turns it into a dynamic, evolving collaborator. Through its transparent file-based storage, its 3 pillars of vector-based memory, and its React-driven summarization, it continually refined its understanding of you.
Yeah, it becomes a partner.
It learns from its past tasks, it optimizes how it uses its tools, and it does all of this while keeping its brain stored in plain text files that you completely control. It isn't just curing AI amnesia, it is laying the groundwork for digital partners that actually grow alongside us.
This raises an important question, though. A deeper philosophical implication to consider as you experiment with these tools. Since ReMe stores its memory as literal, plain text, markdown files.
So you can just open up.
Exactly, files that the AI uses its reasoning framework to read, edit, and continually rewrite. What does it fundamentally mean for our relationship with AI when you can simply open a folder on your laptop and read the AI's documented opinions about you?
Wow, that's wild to think about.
What will it feel like to read the AI's recorded observations about your coding habits, your communication style, and your personality? And perhaps more importantly, what happens to the authenticity of that relationship when you manually open that text file, delete a paragraph you disagree with, and literally rewrite the AI's memory of who you are?
That is a wild thought to leave you with. Taking a red pen to your AI's diary to curate its perception of you. Thank you for joining us on this deep dive into ReMe. Go check out your Markdown files, and we'll catch you next time.